Hi everyone. Now in today's video lecture we will look how ionization energy or ionization enthalpy varies in a given transition series, right, or varies for transition elements. First of all, what is ionization energy? It is the amount of energy required to remove the outermost electron from the atom, right? So the energy we need to find out or we need to know the factors on which the energy required to remove the outermost electron depends, right? So first, this is the energy required to remove the outermost electron, and this depends on first atomic radii, right, and it also depends on nuclear charge. We are already familiar with all these concepts, right? Nuclear charge. If suppose this is your nucleus and this is your outermost shell, you have two electrons, right? As this outermost shell will keep going away from the nucleus, right? We know nucleus has a positive charge and electrons are negatively charged. So as the distance of outermost shell, right, from the nucleus keeps on increasing, so what is actually happening is the atomic radii is increasing, right? So the attraction by the nuclear charge will keep on decreasing, right? So when the attraction by the nucleus on the outermost electron will go down or will decrease, less amount of energy would be required to remove this outermost electron, right? So first thing, the nuclear charge will impact the ionization energy, right? As the distance of the outermost electron from the nucleus will increase, the ionization energy will decrease, right? Why? Because the force of attraction will keep on decreasing as the outermost electron will keep moving away from the nucleus, right? And atomic radii, same thing. As the atomic radii will increase, the distance of outermost electron from the nucleus will increase, right? When the distance of the outermost electron from the nucleus will increase, there is less force of attraction that this nucleus will exhibit on the outermost electron. When there is less force of attraction, that means less energy needs to be given in order to remove the outermost electron, right? So with increasing atomic radii, your ionization energy will go down, right? And with increasing nuclear charge, when the nuclear charge will increase, the force of attraction on the outermost electron will increase, right? If we keep the number of shells same and keep on increasing the nuclear charge we know is positively charged and electron is negatively charged. So if I keep on increasing this positive charge, it will attract the outermost electron with a greater and greater force, right? When the force of attraction will increase, it would be difficult to remove this outermost electron, or we need to give more energy in order to remove this outermost electron. In other words, it's increasing your ionization energy, right? So ionization energy now will increase with nuclear charge, right, and it will decrease with increase in atomic radii, right? So this is the basic concept that we need to learn, that we need to know. Now we know that in a period, suppose this is the first transition series that starts with scandium, right, then comes with your Ti, and here you have calcium in S block. First element you have calcium, then first element is potassium, then calcium. If you move further in P block, you have bromine, right? Now ionization enthalpy or ionization energy of D block, right, lies between S and P block, right? It lies between S and P block. Now that means the ionization enthalpy is greater than S block elements but less than P block elements for transition elements, for D block elements. So ionization enthalpy for D block elements is less than ionization enthalpy of S block elements. Similarly, ionization enthalpy of D block elements, right? The ionization enthalpy of D block elements would be greater than ionization enthalpy of S block elements. Why? Because if you go further in the series, or if you go further in this period, fourth period, your atomic number will increase. When an atomic number will increase, your nuclear charge will increase. So when nuclear charge will increase, it will experience a greater force on the outermost electron, so your ionization energy will increase, right? And for P block elements, for P block elements, you can see the atomic number will again be increasing. So nuclear charge for P block elements would be higher, right? So attraction on the outermost electron would be higher, right? So ionization enthalpy would be higher, right? So ionization enthalpy of D block elements would be less than that of ionization enthalpy of P block elements, right? Now let's concentrate only on D block elements, right? You have SC, Ti, V, Cr, Mn, and you have Fe, right? Fourth period or 3D series. This is your 3D series, right? We have now discussed first point, that ionization enthalpy of D block elements will lie between S and P block elements, right? Now the second most important thing is that first ionization, that increase in first ionization energy, will denote first ionization energy with IE1, right? Increase in first ionization energy for D block elements is not regular, right? When we say not very regular, it means that this increase in ionization energy will slow down, right? As you move further in this 3D series, right? The increase in ionization enthalpy will slow down, right? So why this increase in ionization enthalpy will slow down? We have discussed this in previous lecture, that as you move further in the series, right, towards P block elements, the number of D electrons will keep on increasing, right? And these D electrons will exhibit a shielding or a screening effect on the outermost electrons, right? So that means if this is your outermost electron, right, and this is your penultimate shell that has D electrons, n-1, let's take it over here. This is your outermost electrons, outermost shell, and this is your penultimate shell, right? And this is your nucleus, positive charge, right? Earlier, when there were no D electrons, right, so this nucleus was experiencing a force on the outermost electrons. But when the D electrons will keep on increasing, right, in the penultimate shell, when the D electrons will keep on increasing, they will act as a shield, because they experience repulsion, right, and they have a tendency to increase the electron cloud. Now they will act as a shield between this nucleus and the outermost shell. So when they act as a shield, the force of attraction of this nucleus with the outermost shell electron will decrease. When the force of attraction will decrease, then you can just imagine yourself, when the force of attraction of this nucleus from this outermost shell electron will decrease, now you have to give less energy in order to remove this electron, right? So what is causing this? The presence of these D electrons in the penultimate shell, right? So D electrons will cause screening effect or shielding effect that will decrease the force on the valence shell or outermost shell electrons, due to which the increase in ionization enthalpy or ionization energy would be slow, right? Because now you have to give less and less energy in order to remove the outermost electron. That means your ionization energy is decreasing, right, due to the presence of these d electrons. So this is not very regular due to screening effect or shielding effect of d electrons. That means electrons in d orbital, d electrons, due to shielding effect of d electrons in penultimate shell. Right? I hope the second point is clear. Why the increase in ionization is not regular, right? Why the increase in ionization energy slows down? Due to the shielding effect of these d electrons in the penultimate shell, right? In short, these d electrons are coming in between nucleus and the outermost shell, right? Due to which the force of attraction on the outermost electron reduces by the nucleus, right? And your ionization enthalpy will decrease. Now you have to give it less energy. Now the third point, other point is that the ionization enthalpy of third transition series is more than the first and second transition series, right? This point is important. Right? The first ionization enthalpy of the elements of third transition series are higher than the elements of the first and second transition series. Right? Let me just write it down over here. The first ionization energy or ionization enthalpy of third transition series is higher than first and second transition series, right? Just understand, you have, this is your 3D series, you have 4D series, you have 5D series, right? This is your first transition series, second transition series, third transition series, right? Normally what happens is that as you come down, right, your atomic radii will increase, right? And here we have discussed that with ionization energy will increase with nuclear charge and decrease with atomic radii, right? So when you come down to the third transition series, the atomic radii would be maximum, right? It would be more for the third transition series. So ideally the ionization energy should be less for the third transition series, but it is noticed that ionization energy is less, right, for the third transition series. Ionization energy, it's higher, ionization energy of the third transition series is higher, right? Ideally it should be lower because your atomic radii will increase when you come to third transition series, right? Now the reason for this higher ionization energy of third transition series is because of the presence of f electrons, right? Till second transition series you would not be filling up f electrons, there are no f orbitals. So when you come to third transition series you will start filling up f electrons, right? So in the third transition series, let's take an example of an element of the third transition series. We'll start filling up f electrons from hafnium, right? From hafnium we'll start filling up your f electrons. So the electronic configuration of hafnium would be 4f4 5s2, right? It would be 4f4, it's 4f4, then you have 5d2, then 6s2. This is the electronic configuration. So here you are filling your f orbitals, right? And f orbitals, if you look at this, this is your sixth shell is the outermost shell, and your fourth shell, this is your fourth shell where you are filling up f orbitals, right? So in the second transition series, you have d orbitals, and here we have discussed that ionization enthalpy, increase in ionization enthalpy is not very regular, right? Or increase in ionization enthalpy will slow down, right, due to shielding effect of d electrons, right? Now here you have shielding effect due to f electrons, right? But shielding effect is very less in case of elements of third transition series. The reason being, due to peculiar shape of f orbitals, they could not exhibit, or they could not produce a better shielding effect. The shielding effect is very less, right? So when the shielding effect is very less, the force of attraction between nucleus and the outermost electron will increase, right? So your ionization energy of third transition series would be higher than the first and second transition series, right? The simple reason is these f electrons cause poor shielding effect. The shielding effect due to f electrons is poor in case of elements of third transition series, right? Since the shielding effect, if these are your f electrons and they cause poor shielding effect, then poor shielding effect means now there is more force of attraction between nucleus and the outermost electron. When there is more force of attraction, that means you have to give more energy. When you are giving more energy, that means your ionization energy is higher, right, than first and second transition series, because in first and second transition series you do not have f electrons, right? When you do not have f electrons, the shielding is due to d electrons, right? And shielding due to d electrons we know is good, right? When shielding due to d electrons is good, then it will cause lesser force of attraction between nucleus and the outermost electron. So your ionization enthalpy would be less, right? I hope this is clear. So the simple answer is that ionization enthalpy of elements of third transition series is higher, right, due to poor shielding of outermost electron by the f electron, right? And poor shielding due to f electrons is due to their peculiar shape, right? So this is due to poor shielding or screening effect of f electrons, and why? Due to their shape. Right? I hope this is clear. Now we need to go through one more important thing. We need to look at the thermodynamic stability of compounds, stability of transition metal compounds, right? How can we relate stability of transition metal compounds with ionization enthalpy, right? Let's look at this. We'll take example of two elements, nickel and platinum. We know that nickel exists in +2 oxidation state and +4 oxidation state, right? So we'll just now look at that. And your platinum also exists in +2 and +4 oxidation state, right? So let's quickly, I'll just rub these off. Right. So if in order to reach a particular oxidation state, right, for example, you have nickel, you need to take it to +2 oxidation state. You have to remove 2 electrons from the outermost shell of electrons, right? So when you remove 2 electrons, when you remove first electron, this is your first ionization enthalpy, right? When you remove the second electron, it would be your second ionization enthalpy, right? So energy required to remove the second electron is your second ionization energy. Energy required to remove the first electron is your first ionization energy. Similarly, if you want to reach at oxidation state +4, you have to remove two more electrons. So ionization energy would be third ionization energy plus, in order to remove fourth electron, it would be fourth ionization energy, right? So the more easily an oxidation state is reached, that is, the lesser is the ionization energy, the more stable is the compound, right? Lesser ionization energy means you need to give less energy in order to attain a particular oxidation state, right? For example, let's just look at the data. You have nickel, you have platinum, right? Then you have IE1 plus IE2, right? Now if we talk about we have 2.40 into 10 to the power of 3, 2.49 10 to the power of 3. This is the ionization enthalpy. Now in order to reach 2 oxidation state 2, right? Similarly for platinum, the energy required is 2.66 into 10 to the power of 3 in order to reach oxidation state 2, right? Now lesser energy is required in case of nickel, right? The first and second ionization energy for nickel is 2.49 into 10 to the power of 3, whereas for platinum it is 2.66 into 10 to the power of 3. So lesser energy is required in case of nickel, right? So compounds of nickel in +2 oxidation state would be more stable compared to compounds of platinum in +2 oxidation state, right? I hope this is clear. Now let's look at the second and fourth ionization enthalpies, third and fourth. Just take this off. IE3 and plus IE4, right? So the third and fourth ionization energy would be right. Now total energy, sum of all these would be, in order to reach +4 oxidation state, right? If you add all these, you will get 11.29 into 10 to the power of 3, right? All this is in kilojoules per mole, and 9.36 into 10 to the power of 3, right? This is to reach +4 oxidation state, right? So in order to reach nickel 4 oxidation state, you have 11.29 into 10 to the power of 3, right? And in order to reach platinum 4, you give 9.36 into 10 to the power of 3 kilojoules per mole. So here, in order to reach +4 oxidation state, you are giving less energy in case of platinum, right? So compounds of platinum where its oxidation state is 4, right, are more stable, whereas compounds of nickel where its oxidation state is 4 is less stable compared to platinum, right? Because more energy is required to reach this oxidation state, that is, more energy is required to remove 4 electrons from the outermost shell in case of nickel, whereas less energy is required to remove 4 electrons from the outermost shell of platinum. That is why compounds, if you there is a compound, it's K2PtCl6, right? where platinum is in +4 oxidation state, right? This compound is known, right? Whereas the similar compound in case of nickel is not known. Why? Because its ionization enthalpy is more. When your ionization enthalpy is more, it is difficult to reach this oxidation state. When it is difficult to reach this oxidation state, that means the compounds in which nickel is in this oxidation state are less stable, right? So in short, we say that the easier an oxidation state is attained, the more stable is the compound, right? This is the crux of the matter. Easier an oxidation state is reached. When we say easier the oxidation state is reached, that means ionization energy is less, or less energy is required. Ionization energy is less, right? Then more stable is the compound. More stable is the compound, right? I hope this is clear. So we have discussed here ionization energy, how it depends on atomic radii and nuclear charge, and ionization energy, right, will increase with nuclear charge, decrease with atomic radii, and this it lies between S and P block elements, and increase in ionization energy in a series is not very regular due to shielding effect of d electrons, right? And ionization energy of third transition series is higher than that of first and second transition series due to poor shielding effect of F electrons, right? And the more easily an oxidation state is reached in a compound, in transition metal compounds, the more stable is the compound, right? I hope this is clear. Thanks.